Today's notes are on is on inverse variation. So first we have to understand what inverse variation is. But in all these problems, you're basically just looking at a fraction that's got variables on the bottom. But to be more specific, an inverse variation is a relationship. Spell this correctly. A relationship with two variables where when one increases, the other decreases. All right, so there's a couple things that we're going to do with the inverse variation, and the first is that we are going to look at a table and decide if it's an inverse variation function. So let's look at example 1. On the first example, the first thing we need to look for is that if the x's are going up, the y's are going down, or vice versa. So number 1, x is going up from 1 to 12, and the y's at the same time are going down, so that is the first check. The second check is we need to see if there's a constant between all of them that remains the same. So the way we look for that is we look for their product of x and y. So to figure out the product, we take 1 times 12, which is 12, 2 times 6 is 12, 3 times 4 is 12, and if I keep multiplying x and y, I'm going to get 12. And so, yes, this first one is an inverse function, and the reason is because the xy product is constant at 12. Now we're going to look at the equation here in just a minute, and you'll see what the constant is and where the 12 would go, but it's always remaining the same. It never changes, so it's the same factor every single time. Now, if I look at this on number 2, I see the x's are going up, and at the same time the y's are going down, so it meets the first check, but the second check is to look at the xy product. So 1 times 20 is 20. This would be 34, 42, 44, so we can see they're clearly not matching, but I'm going to have you fill in all the numbers anyway. So is this an inverse variation? And the answer is no. And this time, our reason is the xy product is not constant or the same. Okay? So now let's think about the actual equation. So if we have two variables x and y, and if they're part of an inverse function, then we say that x varies inversely with y. And when we write that as an equation, our equation is y equals k over x, and k equals the constant of variation. Now, we are not going to write the equation for number 1, but in this original one on this table, this right here, this is my constant. This is my k. That's 12. So if I were to write the equation, my k would be 12. So each unique equation has a different k. The y and the x will always remain. We're just going to keep changing this k. So let's look now at writing the equation. So on example 1, it says that we have an inverse function, and they give us x is 10 and y is 3. So they're giving us one specific scenario. In this specific case, x is 10 and y is 3. So using that information, figure out what the equation was to get us that information. Well, we know the equation that we have to work with is y equals k over x. So we know y is 3. We don't know k, but we know x is 10. So to solve for what we don't know, we're going to multiply both sides by 10, so k is just 30. But the question doesn't say, what is k? The question says, what is the equation? Well, now that we know that, in these equations, the y and x always remain. It's just the k that's different from equation to equation. So in this particular example, y equals 30 over x. So now the question says, given this equation right here, now that you know it, let's figure out what it is in other examples. We knew this one here, but now let's figure out different ones. So I'm going to say, well, what is y when x is negative 6? So I'm going to do 30 divided by negative 6. So I get negative 5, so y is negative 5. All right, let's try this again, coming up with different equations. So on number 2, it's another inverse function, so we know that it's going to be in the format y equals k over x. So we know that y is 1/2, and it equals k over x, which is 6. So to solve for k, I'm going to multiply both sides by 6. Before I multiply, I want to reduce, so k equals 3, which makes sense because 1/2 of 6 is 3. But this is k, and they want the equation. Well, the equation is always in this form, but the y and x are going to remain. It's the k that's going to be different each time. So my equation is y equals 3 over x. So now the question says, part B, if you know the equation, let's figure out what an x and y would be in a different situation. So in this different situation, they want to know y when x is 15. So we have 3 over 15. Well, 3 over 15 reduces not to 5, but to 1/5. All right, let's try one more together, because I want to keep this video relatively short. Okay, so we know that it's an inverse function, so it's got to be y equals k over x. So my y is 1/5 equals k over my x, which is 4. So to solve for k, I'm going to multiply both sides by 4. I'm going to put that over 1. Nothing reduces, so I'm going to multiply straight across the top, and k equals 4/5. So my equation, now look what happens when it's a fraction. We're going to write the 4 in the numerator and the 5 in the denominator. But this x, the x for it to be an inverse function has to go in the denominator. And if it's anywhere else, it's going to cause a problem. All right, now let's figure this out for part B. Given this equation, what would it be if x is 4? So I'm going to plug that in. So I need to know y when x is 4. So I'm going to 5 times 4. So we have 4 over 20, which again reduces to y equals 1/5. It's not always going to be 1/5 though. Okay, 4 works the exact same way. I'm just skipping it so we can keep things going. Okay, in the second part, we're going to look at the graph. And when we look at the graph, before we start plugging numbers in, since I don't know, this is the parent function here. And since I don't know what the parent function looks like, I'm going to create a table of values by randomly plugging in different x values so I can figure out what the y values are. But before I do that, I've got to think about some things that are going to happen. I can plug in any number I want to for x, but what can't happen is I can't divide by a 0. This bottom can't be 0, okay? So x cannot equal 0. So 0 cannot be something I plug in here. Okay, so on my graph, any place where x equals 0 cannot be touched. So at 0, 0 can't happen. 0, 4 can't happen. 0, negative 5 can't happen. So any place along this, and I'm going to draw it as a dashed line, any place along this line my graph can't touch. Okay, most people can see that. The confusing one is you have to look for these functions if there's anything that y can't be. Well, y, f of x really means y. So is there anything that I can't get as an answer? Well, the one thing that I can't get is 0. So why can't I get 0? Well, if I've got a fraction, the only way to get 0 is if I have 0 divided by some number. But because the top is always going to be 1, the top can never be 0. So therefore, my answer can never be 0. And therefore, y is never going to be 0 either. So I'm going to have a second line here. My first line was at x equals 0. My second one is at y equals 0. And my graph will never be able to touch it. So those lines have special names, and they are called an asymptote. And an asymptote is a line that the graph approaches. So it's going to get really, really close to that line, but it's never actually going to touch that line. Okay, so because this is a parent function, we need to get some actual points that we can plot because we don't know the pattern yet. We will, but we don't know it yet. So we can't plug in 0, so the next easiest number to plug in would be 1. Well, if I plug in 1 to this equation here, I get 1 over 1, which is just 1. So the first ordered pair I'm going to plot is 1, 1. Okay, well, let's see what happens when I do the next number. How about 2? If I plug in 2, I get 1 over 2, which is 1/2. So I'm going to plot the point 2, 1/2. I keep going. What if I did 3? That'd be 1 over 3. So I get 3, 1/3. I'm not going to write up my table, but 4 would be 1/4, then 1/5, 1/6. So as you see, as I go in this way, it gets really close to my line, but it's never going to quite touch 0. Okay, well, the graph just doesn't start at this point. We have to know what happens over here on the left. So let's try putting in something in between 0 and 1. So what would be in between 0 and 1? How about 1/2? So the question is, how are we going to plug in 1/2? Well, I'm going to come over here and show my work out here so you can see what I'm doing. So I'm plugging in to 1/2 into my equation 1 over x. So that means I'm going to have 1 over 1/2. Well, that's really weird. But a division, or a fraction bar means division, so this is really 1 divided by 1/2. Well, that's still weird. I can't divide by fraction, so instead I multiply by the reciprocal. So this is 1 times, the reciprocal of 1/2 is 2. Well, 1 times 2 is 2. So if I plug in 1/2, I get 2. Well, with that same thinking, if I plug in 1/3, I get 3. And 1/4, I get 4. So this graph is going to keep going and get really close to that line but never touch it. Okay, so we understand what happens now if we put in positive values for x, but we don't understand what happens when we put in negative values. So I'm going to start by putting in -1. Well, that's 1 over -1, which is just -1. So I've got -1, -1. The same thing is going to happen when I plug in -2. I'm going to get -1/2. Okay, and when I plug in -1/2, I'm going to get -2. So it's still my same values. It's just going to be negative. So now my graph looks like this. Okay. For all the graphs we are doing in this lesson, they are going to occur in the top right and in the bottom left. There's no other options for this lesson. As we move forward, that will change. But as of today, top right, bottom left. So if you ask why are they always there, because in this lesson, they're always going to be there. We're going to start with the parent function and just work from there. Okay, so we have to understand a couple key features. The vertical asymptote is the line where it approaches the vertical line but nothing touches it, and that's going to be x equals 0. The vertical asymptote is always going to start x equals, and then some number. The horizontal asymptote is what approaches the horizontal line of y equals 0 but never touches it, so that's your horizontal asymptote. Your domain is your x values. And your domain, well, it's going to, domain says, what can you plug in for x? Well, I can plug in anything, but I couldn't make the bottom 0, so I couldn't plug in 0 for x. So anything but x cannot equal 0. And the range, what about those y values? Well, I can come up with any number for y, except I'll never be able to make y equal 0. All right, so now that we've seen the parent function, let's see if we can find the horizontal and vertical asymptotes for just some basic functions. So looking at number 1, the vertical asymptote is asking the question, what number can x not be? Well, it can't be anything that makes the bottom 0. So what would make that bottom 0? 2. So my vertical asymptote is going to be a line at x equals 2. Okay. The horizontal asymptote is asking the question, what can y not be? Well, this fraction right here can never equal 0. Okay? It can never equal 0 because we'll never be able to have a numerator of 0. Now, if that fraction were to equal 0, and I'm saying that it can't, but if it were to be 0, then y, or f of x, would just equal 7. So since it never can equal 0, it can never equal 7, and so that is my horizontal asymptote. On number 2, the vertical asymptote is asking what can x not equal? Well, it can't equal what makes the bottom 0, which would be -8. The horizontal asymptote is what the y can't be. Well, because this fraction is never going to be 0, the only way to make y equal 2 is if this equaled 0, but it can't equal 0, so the only thing it's not going to be is 2. So the vertical asymptote is the opposite of what's on the bottom, 5. The horizontal asymptote is the number at the end. So you're changing the sign for x, but keeping it on the y. So here x is -11, here y is -20. But notice that every time I wrote x equals and y equals. If you don't write that, you're going to miss points on your next quiz and test. Okay, let's practice graphing. Now it says graph, but this is really going to be today more of a sketch. So the vertical asymptote is x equals what makes the bottom 0, which would be -3. The horizontal asymptote is y equals the number at the end, -4. So the first thing you're going to do is graph x equals -3. Well, that's all the points where x is -3, which is this line. And my graph can never be touching that line because x can never be 3 in my problem. Okay, my horizontal asymptote, so this line was x equals -3. My horizontal asymptote is a horizontal line at y equals 4. So my graph, none of the points can ever touch this line here. Now when I go to graph it, today we're really going to do a sketch, but I want to get one exact point. And the one exact point we always know. Remember I said today it's always going to be in the top right and bottom left. So you're going to go 1 over to the right and 1 up. So you're going to start here as 1 point, and then it's going to get really close to this line and really close to that one. And then over here, you're going to have a point that's 1 away, and we're going to get really close here and really close here. Now we could have done exact points. Okay, over here, our point started at the center, went over 1 and up 1, and went over 2 and up a half. So we could do that. We could start at our center where the asymptotes go, over 2 and up a half. That would work. Okay, so they do work. Okay, domain is going to be all real numbers, except x cannot equal whatever this was. X cannot equal -3. That's why we set it as an asymptote. Okay, the range is all real numbers, except y cannot equal this value, which is -4. Again, that's why we made it an asymptote, because our graph can't ever touch it. On number 2, the vertical asymptote is x equals 1. The horizontal is y equals 2. So I'm going to graph a vertical line at x equals 1, and I'm going to graph a horizontal line at y equals 2. Those are my asymptotes, which means the graph can't touch those points. So that's why my domain is all real numbers, except x cannot equal whatever the asymptote is, because my graph can't touch it, so it can't equal 1. And my range is all real numbers, except y cannot equal what the asymptote is of 2. And now to graph it. Again, all the graphs today are in top right and bottom left. So the first point is going to be an accurate point that's 1 away. And then we're going to go up here. And then we're going to go 1 away. We're going to go here. So it's going to get really close to the line, but not touch it. Okay, number 3 we'll do together, and then you can figure out 4 on your own. So the vertical asymptote is x equals 4. Horizontal, y equals -3. So the domain is all real numbers, but x cannot equal 4, and the range is all real numbers, except y cannot equal -3. So I'm going to have a vertical line at x equals 4, showing me that my graph can never touch this line. And I'm going to have a horizontal line at y equals -3, showing me that my graph can never touch this line. So today we are going to have a sketch. So my first point is going to be over 1 and up 1, and then it's going to get really close here, and really close here, and really close here, and really close there. And that's our graph. Same thing on number 4.